Okay, so let me start filming this again. The question is, there are 8 dancers in a dancing competition. Judge X and Judge Y each put 8 dancers in rank order. Rank 1 is for the best dancer. Now, here, they have given you extra boxes. You really need to use it, because it costs money to print all these extra things for 150,000 exam papers. So, here is where you're going to put the difference, as I've put before, and here's where you put the difference squared. Okay? As those are part of the Spearman's rank equation. So, 2 take away 4 is minus 2. If you are not confident with your negative numbers, then what you need to understand is that you can just look at the difference between those two numbers, and if the first number is smaller, you know the answer will be negative. If the first number is bigger, then you know the answer will be positive. So the difference between 5 and 2 is 3. First number is bigger, so it's positive. Difference between 1 and 5 is 4. First number is smaller, so it will be negative. So that's just an example of how you can do it if you are not confident with negative numbers. Otherwise, not much. Otherwise, 4 take away 1 is 3. This is minus 2. This is 0. This is 5. This is minus 3. So the difference squared. Now, standard deviation and Spearman's rank and most other measures, including chi-squared, the reason why we square the data, the reason why we find the sum of differences squared, which forms the basis of many of statistical calculations, is because we don't want these negative numbers affecting things. So we're looking for the magnitude of the difference, we're not looking for the parity, which means whether it's positive or negative. So don't forget to always square your differences. So 2 squared is 4, because we know two negatives make a positive when you multiply. 3 3s are 9, 4 4 is 16, 3 3s are 9, this is 4, this stays 0, this is 25, and this is 9. So now we have the difference squared. It is at this point that I will draw your attention to the Spearman's rank coefficient, and we need to write that down now. So I'm going to write here 1 minus 6, the sum of difference squared, and we put that over n times n squared take away 1. So we've got our difference squared. The next thing we need to do is sum it. So we need to add all these numbers up together. You can feel free to do this by hand, or because you are in a test situation, you can feel free to use a calculator, because you're allowed calculators in this test. So I'm going to opt for a calculator, the one on my phone, and I'm going to add this now. 4 plus 9 plus 16 plus 9 plus 4 plus, well, 0, so we'll leave that, so 25 plus 9 equals 76. Let's just make sure we got all them. 4, 9, 16, 9, 4, 25, 9. Yep, 76. So I'm going to put my sum here. Sum equals 76. So now this becomes 1 minus 6, 76, because that is the sum of these squared. And we need to work out n. N is the number of dancers, and that's 8. So we're going to put 8. 8 squared minus 1. So 8 squared is 64. 1 less is 63. So now we need 8 times 63. Again, we go on the calculator. We do 8. Whoops. We do 8 times 63. We get 504. So equals 504. So now we're going to do 76 times 6, and we have got 456. So we've got 456 over 504. That is this element here, and we're going to take that away now. So 456 divided by 504, we've got 0.904, and it goes on. Now we're going to do one, take away this answer. So 1 minus 0.9047, and we have got 0.0953, and there is our final answer. Now, typically, let's look at part B. Typically, to make really sound statistical calculations, you would have statistical tables to interpret this for you as to its level of significance. However, this number is pretty close to 0. I think we can say that. Yeah, it's really just 9%. It's not that close to 0, but it's certainly going to be difficult for it to be any kind of statistical significance. We're looking at it being around about the 0.5 to 0.6 mark as a minimum for this size for it to be statistically significant. So I think at this size, being so low, without statistical tables, it is safe to say that there is not any statistically significant correlation between the two grades. So we're going to write exactly that right now. Here is what I've written. There isn't a statistically significant correlation between the two judges' scores. This right here will get you your full 5 marks.